try to predict something about a population, you've got to make sure that, yeah, you do want to take as big a sample as possible, but you never take a sample that's more than 10% of the population. So if Maryville High School has 1,400 people, you don't want to take a sample bigger than 140. Hopefully you already know the answer to that. As n increases, the sampling distribution of p hat becomes approximately normal. The second sentence is the answer to Meredith's question. How many people do I need to sample to make sure that it is normal? Is answered in the second half of the question. You have to know that. You have to reference it on pre-response questions. We said earlier that the shape of the distribution of p hat depends on the sample size and the population proportion. Now we know exactly what it has to be. For your distribution of p hat, the sampling distribution of p hat, for the distribution of all p hats to be normal, n times p and n times q have to be greater than or equal to 10. Just to clarify, q is just the probability of failure, right? If this is the probability of success, that would be the probability of failure. So if p is the probability of an orange Reese's, that'd be the probability that it's not orange. You've got to check that before you use a normal condition. Meaning if you go to use table A in the back of the formula sheet and you haven't written that, you're not getting credit for what you use on table A. Even if you do everything right. You do normal CDF and you find some probability. If you didn't first say it was normal because of that, you can't do it. So you need to make sure you know. No. Maybe. Any questions on those two conditions? I'll make sure you have both started. Gotta know that. You don't sample less than 10%, you can't do this because it doesn't mirror a binomial situation. It doesn't have to, especially your question was, does it have to be binomial? It doesn't have to be binomial, but it's going to mirror a binomial situation. Right? A binomial distribution. If it doesn't, you can't use it. So you've got to check to see if you sample less than 10%. And then if you want to use normal probability, meaning table A or normal CDF, you've got to check that n times p and n times q are both bigger than or equal to 10. Less than or equal to 10% of the population, bigger than or equal to the number 10.
Wait, so if it's not a binomial distribution, you cannot use these ones.
It doesn't mirror a binomial distribution.
Okay. Is it going to? Are we
Yeah,
getting a
you're
problem?
checking to see. I mean, if we're doing the probability of, if we're looking at p hat, we're looking at those orange M&Ms, orange Reese's, right? Either orange or it's not. It's binomial.
Plus 10%.
If I check less than 10%, and so 25 out of that giant thing, we would assume there's more than 250 in there. Right? The number we're talking about, well, my samples there were 25, right? Or then I ended up taking samples of 100, or even if I took samples of the last two, right? And it's 0.5 each.
So if it's, will it
The only
ask-
one you really have to check is that. Okay. They love to put these, I would almost guarantee you will see a question about this on the AP exam in the multiple choice section. Before you start filling in the blanks, let me explain it and I'll give you time to fill in the blanks. Think about what we've been doing here. We've been looking at sampling distributions of p hats. We've been looking at all these p hats, right? And we know that if n times p, first of all, quickly, what is n here?
Whisper.
Use a different word than trials.
Samples.
Not samples. Scary.
number,
Size of.
Size of your sample. That's sample size. Not the number of samples. The number of samples would be how many samples you take over here, right? Which is hopefully all of them, but we know it can't be all of them, so we want to take enough. The number of samples times the probability of success, meaning the population proportion, the parameter if you want to. has to be greater than 10. But so does sample size times 1 minus the parameter. So let's go back to those orange Reese's. What was P? 0.5. So you should know right now, to be able to have a normal distribution over here, for it to end up looking normal, now I'm going to just start using dot. For it to look normal, end up with a normal distribution, you know you'd have to take a sample size of at least what?
20.
20. Why 20, Spencer?
Well, no, 21.
Why 21?
Because that'd be greater than 10.
Yeah, you need both to be greater than 10. So we know to have a normal distribution, we've got to take sample sizes greater than 20. Why? Well, because we know we want n times p to be greater than 10, and n times q to be greater than 10. And if p is 0.5, then q is 0.5. We divide both sides by 0.5, we've got n's got to be greater than 20. We've got to sample more than 20 if we want a normal distribution. Why would we want a normal distribution? So that we can use table A. Everybody follow? Okay? Now notice what it says. The standard deviation of p hat. You should know what it is. Not memorize, just look at it. What is it? Standard deviation of p hat.
The square root of PQ over
Does it say p on the formula sheet?
No, it says
P times 1 minus p?
1 minus P.
Is the n in the parentheses or not?
It's,
I'm sorry, in the radical or not?
yes, it's all under the radical.
Thank you. As you can tell, I use the formula sheet as well. I don't remember it. We'll need to. Now, what do we know about that? We know that we want the standard deviation to be what? What do we want it to be? Why 1?
Zero.
Why do we want it to be 0?
Macaroni and Chris Ray.
There's no average distance from the mean.
Okay. So there's no average distance from the mean,
And they're all the same.
which would mean what?
It's perfect.
Papa
You're very
John.
confident. Right? If I said, hey, I'll give you $100 if you can guess the number I'm thinking of. The number I'm thinking of is 5. That's the situation you want, correct? Now, let's be reasonable here and go, all right, we're probably
least
not going to
10.
make the standard deviation 0. So let's don't give a value, but give the type of value we would want. We want the standard deviation to be what?
Whoa.
Small.
As close to 0 as possible.
Close to 0 as we can possibly get. All right? The smaller it is, the more confident I can be about my guess. Because I'm guessing from a smaller amount. Okay. So if I want it to be smaller, think about this. Can you control the population proportion? There's two things that affect standard deviation, P and N, right? You're studying, you want to find the proportion of females in Marable, and you want a low standard deviation so you can be real confident. Can you control the population proportion of females in Marable?
No.
Not legally. Right? Please think about this. You can't do anything about that. You're not going to control the thing you're trying to predict. You don't even know what it is. And if you do control it, your study's invalid because you've changed the actual situation. What's the only thing you can control? N, because what's in?
Sample size.
Sample size. Now think about this. If I want this to be smaller, I want to divide by what? A larger number. The bigger this is, the smaller it gets. You divide something by 2, that's bigger than when you divide something by 100, which is bigger than when you divide something by 500. So the bigger the sample size, the better. Now, the question on the AP exam won't be how big of a sample size should you take. The question will be like this. Since the value ends under the square root, they won't tell you that, but this is what you've got to understand. Since it's under the square root, if you wanted the standard deviation to be half as big as it currently is, right? Let's say you got a standard deviation and it's 100, and you're like, that's way too big. I'd like for it to at least be 50. If this was 100 you need to do to n to make it 50? What would you need to do to cut the standard deviation in half? Think about it this way. Give me just a number. Let's say we took a sample of size what?
5.
5. Give me an even number.
10.
6. 106.
I'm glad that you're into it. Let's go with 6. If my sample size was 6, and I got a standard deviation of 100, and I was like, that's too big, let's cut it down. Because if I've got a standard deviation of 100, and I check this, then think about this. What's that spread? If I check this, and both of these worked out, and it was normal, and I've got a standard deviation of 100, what's that range?
Large.
Don't tell me large, tell me the exact number, you should know. Oh gosh.
100.
No.
Good job, China.
Well, if it's 102, then it's gotta be.
Checking this ensures what?
That it's in the, that it's gonna be normal.
That it's normal. And if it's normal, what do you know about standard deviations of a normal distribution?
3 is less 3 or less is
There's 68% within the first, but how much of the distribution am I covering here?
100.
So about how many standard deviations should that cover?
3.
3 above and 3 below. So this would be what?
All standard deviations. 100.
600.
So,
If the standard deviation is 100, and I want to cover about 100% of the values, I want to cover from the mean, and then 1, 2, 3 standard deviations over, 1, 2, 3 standard deviations over. What's one standard deviation here?
100.
So 100 plus 100, that's 200.
sure?
Plus 100, that would be 300. Another 100, 400, 500, and this is where it gets confusing. One more 100, that's 600.
What is the square root of 0.5?
Good question.
I don't know. I feel like I'm actually gonna leave that into a question.
Just hold tight. So, what do I know right now? I know that if my standard deviation was 100, my whole range would be 600. That's a lot to pick from. So if I decided I want to cut that down, I don't want to pick out of 600 possibilities. I want to cut it down. And so if I cut that down to 50, how would I cut it down to 50? The sample size is 6, and I want to get half of the size. What'd you say? Make n 30? Why 30? 33.
3.
Make n 3. Okay, make n 3. If I divide by 6 and get 100,
But
and
you
then I
can't
go back and divide by
12. But you're
12.
taking the square root.
yes, that's where I am.
36.
That's like,
24.
if you increase the decimal,
12.
wait, I'm confused on like the closer to 1 thing. or the closer
Make it
to-
12.
Don't worry about that right now. My question is just, how could I cut that in half?
Make
Wow.
n 12.
Make n 12?
Well,
What an Alex.
So, if you divide by 6 here, you get 100. When you divide by 12 here, are you going to cut it in half? No. Why? Because what are you doing right here? You're forgetting some algebra. The square root of an entire fraction is the square root of the top over the square root of the bottom. Do I agree with that?
yes.
So this really says square root of p times 1 minus p all over the square root of 6. This really says square root of p times 1 minus p all over square root of 12. To get half as much, you would have to divide by 2 times as much, correct? That's what I just said. To get half as much, you would need to divide by 2 times as much. Is the square root of 6 times 2 the square root of 12? No. Hopefully you don't know. If you're not sure, take them both to the calculator. That's not double that. What is double the square root of 6? What's the square root of 4?
2.
2. So did I really write 2 times square root of 6 there? Yes, I did. If you can't see that, stand up and make sure you can see what I'm writing right now. If I want to get half as big, I need to divide by twice as much. The square root of 4 is 2 times. 2 times radical 6. But I was asking what my sample size should be. So the square root of 6 times the square root of 4 is the square root of
24.
24. If you wanted to cut it in half, you would need to multiply it by 4. Because what's the square root of 4? 2. If you wanted to cut it into a third, you'd need to multiply by 9, because you'd end up having to take the square root of it. That's what that says. If you don't understand it, you need to read it until you do, or ask questions until you do. You will see one like that on the AP exam. They'll say, all right, here's your standard deviation. What would you need to change your sample size by if you wanted to make it, they'd probably give you a number and say, you've currently got a standard deviation of 500. You want your standard deviation to be 100. What would you need to change your sample size to?
2,000.
Yeah.
The current standard deviation of p hat
Yeah.
is 500. You want a standard deviation of p hat to be 100. Your current sample size is 8. What should n equal? If you go from 500 to 100, you need to divide by 5 times as much. Everybody agree with that? You need to essentially divide by 5, so 5 times as much. But that's not 5 times 8, because we know the denominator in the standard deviation of p hat is the square root of n. So if my sample size is currently 8, I would need to multiply 8 by what?
25.
25. If I want to cut that into a fifth, I need to take the square root of 25, because that'd be divided by 5. So n equals 200. There's quite a bit of work to be done in the actual study. If you wanted to cut your standard deviation down a fifth, it's not just saying, okay, let's sample 40 people instead of 8. You have to sample 200 people instead of 8.
Okay, so like a long time ago, we were talking about how to make like answers most confident. You said like make the standard deviation as low as possible.
Yes,
On
sir.
an AP exam, that wouldn't that be wrong though, because as low as possible you make it. Oh, never mind, okay, never mind, yeah. And then another question. One like on the same issue you were saying to make it. Never mind, let me think about my next question.
Good idea. Any questions here?
You leave it up this way.
Start. If you're not copying the board, I'd be reading the next paragraph in your notes. And then where it says finite population correction, just type it up, just write omit. That's something you'll need to know if you take a higher order statistics class, but you will not need to know that in this class or the AP exam. Good, Andy?
Yes.
Don't need to know that. Okay? Don't need to know it. It's not on the formula sheet. If we had more time, I'd go over it, but we don't. So I need you prepared for the AP exam. That, we've already said, hopefully it makes sense. If our census, meaning if our sample is the whole population, my sampling distribution for p hat shouldn't vary at all, because I'm talking the whole population. Even if I did the sample 100 times, I'd get the same answer all 100 times, because I'm doing the entire population. That's the only way it wouldn't vary, is if I'm sampling the entire population. Alright, let's start trying to cover up some of these answers. See if you can work. Just go to the next page. So the superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a four-year college or university. Right now, you should know what we're looking for. Right, the superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a four-year college or university. What's she want to know? Don't read me the sentence. Summarize it in like a word or two. She wants to know a proportion, be more specific. The population proportion. She wants to know the population proportion. What formula or what variable do we use for that? P, right? We'll just go with P. Pi is right, just the AP exam for some reason doesn't use pi, they use P, so we'll just say P. She wants to know P. She wants to know P. What is P? It's the proportion of middle school students in her district that are planning to attend a four-year college. That is your parameter, meaning the thing we don't know that we'll want to predict. We use statistics to predict it. Alright, starting next chapter, and on the AP exam, you won't have that next sentence, but we're kind of backing into it. Look at the next sentence. Suppose that 80% of all middle school students in her district are planning to attend a four-year college or university. Now, obviously we wouldn't know that. She doesn't know that, or she wouldn't be doing the study. Okay? We're backing into it. Next chapter, you won't know that, but what we just heard is this. We know what P is. P is 0.8. The proportion of all middle school students in that district is 0.8. We're just assuming that. What's the probability that a simple random sample of size 125 will give a result within 7 percentage points of the true value? Now let's take some time to think about that. What's the probability that a simple random sample of size 125, what did they just tell us? So what do we know? N. We knew P for the second sentence. We know N's 125. Will give a result within 7 percentage points of the true value. What are they saying there? What do they mean by give a result?
P will equal.
We know what P equals. P won't change. P hat. Why P hat? What do you mean? Of a sample. Look at that. Read that last sentence. What's the probability that a simple random sample of 125 will give a result? A result for what? The proportion of that sample. So what they're saying is, what's the probability A lot of you are not writing this notation at the beginning of the problem. If we're finding probability, tell me what you're finding. Probability of what?
Middle school students planning to attend
But be a lot more specific, that last question. What's the probability that a simple random sample of 125 will give a result? What do we mean by result? A p hat. What's the probability that p hat will give a result within 7 percentage points of the true value? What do I mean true value?
P.
P is the population proportion. What was the population proportion?
0.8.
So they're saying, what's the probability that when you take p hat of a sample, you get something within 7 percentage points of p? What's the range of values there? 0.73 to 0.87. That's what they just asked. That's the question. Now, how have we found probability all year? Not all year, 95% of the year. When we find probability, what do we use?
A calculator.
What part of the calculator?
Distribution.
Distributions.
Second bars.
Distributions. What distributions have we used the most? Normal distributions. How could we use a normal distribution here? Did it ever say that these students are normally distributed? No.
But we assume that there's more than 1,250 students in the school.
That does what?
Oh, never mind, that's the 10% rule for
Which checks for
independent.
independence. Now, we wouldn't need to say that, right? So we'd say that. We would assume there are more than, for sample 125, 1,250 students, middle schoolers. What did it say? In the school, in a large school district. It's a large school district. I think there's more than 1,250 middle schoolers. But what did that check for? You don't have to write this, but we just checked for independence. Why do we check for independence? Because it's not independent. We can't move on. But that did not check for normalcy. How do we check to see if we're going to have a normal distribution? First of all, what distribution are we even looking at? What do you want to know?
The p-hats.
P-hats. So what distribution do you want to look at?
Samples.
Yeah, all the p-hats, right? All the p-hats. You got to start thinking about this. Have some common sense here. If you want to know the probability that I pick a red chip out of this bag of chips, what do you need to know?
How many chips?
How many chips are in there? You don't need to know about something else. You need to know about the bag of chips, right? So if we want to know the probability that I get a p-hat that's somewhere in there, I need to know about the p-hats. What tells me about all the p-hats? The sampling distribution. So then we need to start looking at, okay, we need to look at the sampling distribution of p-hats. Okay. What do we know about the sampling distribution of p-hat?
If NP is greater than 10, it can be
And.
considered.
And NQ is greater than 10.
Then it can be considered normal.
We can assume it's normal. So we check that first. On our paper, we need to say n times p greater than 10 and n times q greater than 10. Let's check it. N's 125. What's p? 0.8. Hopefully right now you're thinking about a problem we're going to have in the future. Problem in the future is this. What does P stand for? Population proportion, right? Am I going to know the population proportion? So how am I going to check for normalcy when I have to use this thing that I'm not going to know? We'll get there in the future. Right now you know. Okay? 125 times 0.8, is that bigger than 10? Yes. 125 times 0.2, is that bigger than 10? Yes. So right now I can say what? What's it?
The distribution.
Yeah, make sure you're using the correct words. Don't say it is normal on the test. The distribution of p hat, or the sampling distribution of p hat, is approximately, be careful with using those words, approximately normal. What else will I need to know about that distribution?
They're either attending a four-year school or they're not.
Yeah, so you're talking right now, is it binomial? Sure, let's run through those. They're either attending one or they're not. It's independent because there's less than 10%. The number of trials is set, 125. The probability of success is set, we know it's 80%. Okay? So it does mirror binomial, but if I want to find the probability that it's between these two values and I know it's normal, what else do I have to know to find that? Been doing it since chapter 3. Well, somebody, what? The mean and standard deviation. I need to know what the mean of p hat is and the standard deviation of p hat, or else this is all useless to me. If I know it's normal, and I know I want to find between 0.73 and 0.87, but I don't know where they're at, it's useless. So I'm going to know what the mean is. What's the mean here? 0.8. Very good. How'd you know? Because you know the formula on the formula sheet. Just mu. It's mu. 0.8. We knew it. I'm sorry. Not mu. It's p. Standard deviation of p hat. 0.8 times 0.2 all over 125, the square root of that. Help me out there. What is it? 0.0357. So there's 0.8. One standard deviation would be 0.8357. Two standard deviations. What's that? Help me out.
714.
0.8. 0.8357. Y'all have calculators. Come on. Plus 0.0357. One more standard deviation. You've got a calculator. I'm just asking you to type in that plus one more of those. 0.714.
You guys speak like
And then one more. Give me 3 standard deviations. Actually, I don't need one more because I'll be past it right here. What was it, Alexander? 0.87 what? 1.4. Because I just want to know right here to 0.87, so I've covered my bases. There's 0.87 right in there. That's the actual value I want to know about. There is 2 standard deviations, 1 standard deviation. Now I want to go all the way down to 0.73. So right here, 1 standard deviation, 0.8 minus that would be 0.7643. Is that right? Okay. And I haven't covered it yet, so I need to go 2, and I'll definitely need your help here.
0.7286.
0.7286.
Yes.
And I got it. You're the man. Because I wanted to be above 0.73. So I want to know what's the probability. First of all, think about this. What's every single dot in here represent?
The p hat.
And that's why it's so essential that you start labeling these. This whole distribution is just all p hats. It's sampling distribution. It's all the p hats. So if you want to know the probability that you randomly pick a p hat, and every one of those p hats stands for a p hat from a sample of 125, if it really has a proportion, a population proportion of 80%, the probability you pick one between there is that area. So you could not pick it, and you could not pick it, but that's the probability you would. How are you going to find it? Either z-scores or the calculator. So again, have the proper notation. The probability that p hat is greater than or equal to 0.73 and less than or equal to 0.87. I'm going to go ahead and use the calculator. Normal CDF. I need my lower bound first, I got it, 0.73. I need my upper bound next, I got it, 0.87. That's the lower bound, that is the upper bound. The mean of the whole thing, 0.8, the standard deviation of the whole thing, 0.0357. That answer is 9.5 straight out. Okay. What's that mean? It means that if I take a sample of size 125, there's a 95% chance that I'll be within 7% of the actual value. What you just saw, whether you realize it or not, is something we'll be doing in chapters 9 and 10. You've just learned how the very beginnings of a confidence interval. How confident are we? 95% confident. 95% confident of what?
That
The
P
P.
hat will be between 7 full percentage points.
Of the true
P.
value. I'm 95% confident that if I use a sample of 125, I'll get an answer within 7 percentage points of the actual value. Now please understand something here. Does that mean there's a 95% chance that I'll get it right? Not really. I'll either be right or I'll be wrong. Look at all those, right? I randomly pick one from it. Oh, it's not within 7 percentage points. But over many, many, many trials, 95% of the time, I pick one that is within 7 percentage points of the actual value. You found a confidence interval. What do you think would happen if I lowered that number?
It'd be a bigger range.
Yeah, now think about this. If that n gets bigger, what happens to the distribution? It spreads out, right? If it spreads out and I still shade that same area, I'd be less confident. Which should make sense. Because the bigger the sample size, the smaller the variation, the more confident I am. If my sample size was 2, I get these giant distribution, it goes way out here. But if I'm only covering that much area of this thing, it's a lot smaller confidence level. Any questions? All right, I'll let you fill in all the blanks. Here they are. You may have already started filling in. Good start. This is state plan to conclude. We want all of this. You should be able to, by the end of the course, write all of this. Notice how we're using the formula, stating what the formula is, then plugging in, not just saying the mean is this, or the standard deviation is this. You don't get credit if you don't show where it came from. Notice that right there. Standard deviation. I couldn't do it if it was less than 10%. I'm sorry, if it was more than 10% of the population. So I had to check that before I did it. What are we really doing here? If you need to, make a note. What am I really doing? I'm figuring out what all the p-hats look like. Because if I want to know what the probability of getting that p-hat is, I need to know about all the p-hats. So this plan is just going, all right, I need to know what's in the bag. How? Formula sheet. What have we not done so far? Check for normalcy. We've got the mean and the standard deviation, but we can get that even when something's not normal. Can I skip pages?
No.
Can I move? You have to check and see if the distribution is normal. We did that over there. N's 125 times 0.8. N's 125 times 0.2. Those are both greater than or equal to 10. So I'm good, and so I can assume it's normal. What I'd love to see there is for you to go, well, I already wrote it over here, I'm gonna write it again. The distribution of p hats approximately normal. You can do that like this. You remember this? You can say something's normal by just putting in parentheses and then its mean and its standard deviation. What was its mean? 0.8. Standard deviation? 0.03.
357.
That's 357. That's enough. If you got that in your plan, that's good. You could write it all out. We could consider the distribution of p hat to be approximately normal sense, or you could just say, check that. Distribution of p hat is approximately normal with a mean of 0.8, standard deviation of 0.0357.
So technically in this one, if Q, never mind. I was thinking for some reason, 1 minus 0.9 was 1, but it's not.
Yeah, if it's not, then you can't do the problem.
Okay.
If it doesn't check out as greater than or equal to 10, you won't know what to use to find the probability.
I was
Okay.
thinking like 0.2 is Q.
Yeah. And then from here, I've just got the proper notation. We've got to start having that. Some of you are just giving me this. And even this doesn't get you full credit unless you tell me what these are. If you've got what's on your notes right now, you're not getting full credit. So you need that. That's the notation. Probability that p hat's greater than that, less than that, is that. But what are these numbers? That is the lower bound. That is the upper bound. That is the mean of what? Of p hat. Don't just put mean. That's the standard deviation of p hat, of all the p hats. Because if I want to know what's the probability of getting a p hat, I need to know what they all look like. And then finally, your conclusion. Approximately, or about 95% of all simple random samples of 125 would give a sample proportion. Or you could have said right there, instead of saying sample proportion, I could have said there you go. P hat. Would give a p hat within 7 percentage points of the true proportion. Or you could have said P. Hi. Of middle school students who are planning to attend a 4-year college. So you could be 95% confident that if you randomly picked 125 kids from this school district, you would get a p hat within 7 percentage points of the actual proportion. All right, tomorrow. Today we talked about sampling distribution of p hat. Tomorrow we'll talk about sampling distribution of
Thanks, Paul.